All right, let's talk about ionic compounds. Remember, ions are atoms or groups of atoms that possess a net electric charge. They can be positive ions or cations. For example, you can have sodium or calcium or aluminum, all that have positive charges, or polyatomic ions such as ammonium. Remember, polyatomic ions are molecular type compounds, but they have an overall net charge. For the purposes of forming ionic compounds, the ammonium is the one we're going to worry about. Negative ions or anions have extra electrons, and so you're going to get a negative charge, chloride, oxide, nitride, or polyatomic ions like sulfate or nitrate, and we'll learn a list of those polyatomic ions. They're on your ion list that we already mentioned before. For example, sodium chloride, better known as table salt, is a good example of an ionic compound. It's composed of a positive ion sodium and a negative ion chloride. Ionic compounds don't form nice molecules. They form a crystal lattice, which is pictured below. All the ions are stuck together to form a cube in this case. And instead of calling that a molecule, we call it a formula unit. And so when an atom or molecule loses electrons, it becomes positively charged and forms that cation we're talking about. So if you look at the graphic, we got sodium atom with 11 protons, 11 electrons. It's going to lose an electron and become 11 protons and 10 electrons. So it's lost an electron. When we form the anion, it's going to gain electrons, forming an anion. And we've got 17 protons, 17 electrons. It's going to gain 1 electron to have 17 protons and 18 electrons. Now, chemistry often involves the transfer of electrons between substances. In the example of the sodium chloride, there's a neutral atom, sodium, loses electrons to form sodium plus, but that electron can't be just lost entirely, so it is transferred to the chlorine. So the electron the sodium loses is the one the chlorine gains. And you can see that picture here. Here's the picture of the sodium atom losing an electron. That yellow circle represents the electron and becomes the electron that the chlorine atom gains. And then these ions, the positive and the negatives, are attracted to one another and they crystallize together into the crystal lattice. Charge can be predicted on elements depending on the position of the periodic chart for your A group elements. Transition metals, the B groups, are a little bit harder to predict, and we'll usually have to infer what they are. And that goes with elements on usually the 4th row and down in the metals can have variable charges. We'll end up using Roman numerals or OUS or an IC ending to distinguish which ion is which. We'll talk about that when we do the nomenclature. But we can see group 1A likes to form a +1 charge, 2A forms a +2, 3A, like aluminum, tends to form a +3. Not a lot of good rules for 4, but then when we get to rule 5A, -3 for 5A, -2 for 6A, -1 for 7A, and your noble gases don't tend to form ions since they would have a 0 charge or would remain neutral.